Good morning, students. So today we will be discussing on the topic electrochemistry. Okay, so in this chapter, electrochemistry, we basically discuss about electrochemical cell. Okay, so it is something to do with chemical reactions and electricity. Okay, so in this chapter, we basically learn about how the electricity is generated with the help of chemical reaction, or how electricity is used to perform a chemical reaction. So electrochemical cell can be broadly classified into two types. One is called galvanic cell or voltaic cell, another is called electrolytic cell. So galvanic cell or voltaic cell is the cell from which we generate electricity. So that is, from chemical reaction we obtain electrical energy. Now, in case of electrolytic cell, chemical energy, electrical energy is used to perform a chemical reaction. Okay, so in the example of galvanic cell, our voltaic cell is Daniel cell, Daniel cell. Okay, or normally we see battery, car battery, and all. No, so this all come dry cell. Eh? So you suppose this all comes under the topic galvanic cell. Whereas electrolytic cell, we basically talk about electroplating. Plating, electroplating. Okay, so what happens in electroplating? We know that electricity is used to perform certain reactions, to perform the plating. Okay, so here the electricity is used, here the electricity is produced. Okay, the next important topic we have to discuss is Daniel cell. Okay, so the first you have to understand how the Daniel cell works. So how the what we called it is the construction. Okay, so construction of Daniel cell. So I'll do it. So this is one cell, or we call it basically half cell. So this is another cell. Remember, it has a solution, zinc sulfate, aqueous 1 molar concentration, and it has a copper sulfate solution, that is aqueous solution 1 molar concentration. Now one metal electrode or metal plate is dipped. It is made from a pure zinc metal. Okay, so this is basically zinc metal, and here the copper metal is dipped, copper. So we can say this is a copper plate, and so this is a zinc plate. Now this is connected through a voltmeter, then need to do this via external wire. Okay, and there is one called salt bridge. It is nothing, it is basically a U-shaped tube in which it is filled with a saturated solution of KCl in agar-agar. KCl or silver nitrate solution, saturated solution, anything you can use. So this is salt bridge. Okay, so voltmeter, copper plate. So this is copper. So we okay. So this is a salt bridge, right? So if you connect, so this is a solution. So remember, now the cell is zinc sulfate solution 1 molar concentration, copper sulfate solution 1 molar solution, and copper plate is dipped in a copper sulfate, zinc is dipped in a zinc sulfate. Okay, so this plate is connected to the other plate via external wire. So we have a voltmeter, and there is a salt bridge made from saturated solution of KCl in agar-agar. Okay, I'll tell you later on how it is made. Now as soon as you complete this cell, okay, then the reading in the voltmeter comes exactly as a 1.1 volt in this case. Okay, so this is called basically oxidation part, oxidation, and here is reduction. And this is called anode, this is called cathode. Okay, so what is actually happening inside this is, so zinc solid is converting into Zn2 plus ion aqueous plus 2 electron. Okay, so zinc, from zinc it is a pure metal zinc. Okay, from here zinc ion is coming out to the solution as Zn2 plus. Okay, and that during this process it releases 2 electrons, so 2 electrons remains in this plate. Okay, and this goes here by external, so this is the movement of electrons, so this goes to this circuit and it comes here. Okay, so 2 electron comes here in this plate. So this is at anode. Now at cathode, so cathode is this side. Okay, so what is happening is copper ion, so it has a copper sulfate solution, so copper ion, it goes to this plate to become copper. Okay, accepting this 2 electrons, so that is the reaction. So Cu2 plus from the solution aqueous adds 2 electron from the plate, okay, to give copper solid. So what we are saying is that here this electrode is decomposing. Okay, corrode हुँदै जान्छ, सो जिंक चाहिँ यहाँबाट प्लेटबाट तल झर्छ भने यो कोरोड सकिँदै जान्छ, कपर चाहिँ सल्युसनबाट गएर यहाँ डिपोजिट हुँदै जान्छ. Okay, so यो मोटाउँदै जान्छ. So this, now this process, removal of electron, is known as oxidation. So basically oxidation is happening in this cell and the reduction is happening in that cell. Okay, that half cell, because the addition of electron is known as reduction. Okay, now another important point is, since during this process zinc, this plate releases 2 electron, so this plate becomes negatively charged. Okay, this, so we call it anode, but it is a negatively charged. Here it accepts. Okay, so to copper ion, it goes and adds to this plate, so it becomes a positive one. So this is positive and we called it cathode. And the moment of electron is basically from anode to cathode via external wire, and the direction of current is opposite to the direction of electron. Okay, since electron is moving from this anode to cathode, that means the current is moving from cathode to anode. So so this is the direction of current, this is the direction of electron. Okay, there is a remembering technique. Okay, so you have to see the alphabet now. Okay, so which comes first, L or R? So basically L left, L comes first, R comes after that, right? So left, right. So left मा जहिले पनि को हुन्छ र राइट मा को हुन्छ भन्ने कुरा छ है. सो लेफ्ट मा हेर्दाखेरि ओके, सो एनोड र क्याथोड मा को अगाडि आउँछ, ए, राइट. सो एनोड क्याथोड, सो लेट्स लेफ्ट मा एनोड हुन्छ, राइट मा क्याथोड. सिमिलरली ऑक्सीडेशन रिडक्शन ओ कम्स अर्लियर, ओके, इन अल्फाबेट मा. सो ओ आर ऑक्सीडेशन रिडक्शन. सो लेफ्ट मा एनोड हुन्छ र एनोड मा ऑक्सीडेशन हुन्छ, राइट मा क्याथोड हुन्छ र क्याथोड मा रिडक्शन हुन्छ. त्यस्तै प्रकारले चार्ज एन र पी मा को अगाडि आउँछ, एन अगाडि आउँछ हैन. सो त्यसले गर्दा लेफ्ट मा को हुन्छ, नेगेटिभ चार्ज हुन्छ र राइट मा पोजिटिभ चार्ज हुन्छ. इट इज अ लाइक स्ट्यान्डर्ड फर्मेट, यु क्यानट चेन्ज. ऑक्सीडेशन भन्नुसाथ जहिले पनि नक्सा पनि लेफ्टमै बनाउँछ, रिडक्सन भन्नुसाथ जहिले पनि नक्सा पनि राइटमै बनाउँछ. ओके, यो चाहिँ स्पेशल फर्मेटै छ. त्यो अक्सिडेसन हुँदैछ भने त्यो राइटमा हुँदैन, त्यो अलवेज लेफ्टमै हुन्छ.